Hello everyone, happy to see you here. Today we have interesting algebra question a plus b equal to 10 and the product a times b equal to 36. We need to solve this question for a and b, so if you have your solution, your approach, your answer, you can also write it in the comments below and then we will check it. Okay, so how do we solve this type of question? First of all, we just look closely at this first equation, a plus b equal to 10. From here we can easily express this b, so let's do it. Or a, this is up to you. I prefer expressing this b first of all. So b equal to 10 minus a. Okay, so 10 minus a. And right now, let's look closely at this second equation. Instead of this b, let's plug in 10 minus a. So right here at this place, we're going to plug in this 10 minus a. Okay, so let's do it. So we have a times 10 minus a, 10 minus a, equal to 36, and right now let's simplify this expression. Let's say, so we have 10a, let's multiply a by this parenthesis, so we have 10a minus a square equal to 36. Right now, let's change an order, because on the first side, this is a quadratic equation. Here we can easily simplify this quadratic equation. We have square, we have a, we have constant, but we didn't like this order, so that's why we write this minus a square on the first position, on the second position plus 10a, and on the third position minus 36 from the right side, so minus 36 equal to 0. And what we're going to do next? Right now let's multiply both sides by minus 1, because we have a negative sign right here. So we prefer a classic order, so that's why my quick recommendation, quick tip is to multiply both sides by minus 1, and then we will have a classic order, a square minus 10a and plus 36 equal to 0. Okay, we have a classic order. This is a classic quadratic equation, so let's solve it. First of all, let's write our coefficients. So first coefficient a equal to 1 from here, second coefficient b equal to minus 10, and third coefficient c equal to 36. Okay, we have three coefficients. Of course, this is up to you. You can also use theorems, but I prefer a classic method using a discriminant. So that's why I want to solve real quick our discriminant. Solve for discriminant. So b squared minus 4ac equal to, so b squared equal to minus 10 square, minus 4 times a times 1 and times c times 36. Okay, let's simplify it. So minus 10 square equal to 100 minus, right here we have 144, and when we subtract it we have minus 44. This is not a great news for us, because we have right here negative discriminant, so it means that we have two roots right here at this branch, but two complex roots. So as a result, we have two complex pairs of solution, but doesn't matter. Let's solve it for complex roots. So we have a first and a second equal to minus b plus minus square root of discriminant and all over to a. Right, so let's plug in everything. We have minus b minus 10 plus minus square root of discriminant, square root of minus 44, and all over to a 2 times 1. Okay, so how can we simplify it? First of all, right here, minus 10 equal to 10, because minus times minus equal to plus. If you're talking about simpler words, yeah, we have 10 plus minus. Right here, square root of minus 44. We can express this minus 44 as a product of minus 1 times 4 and times 11, all over 2. And right now, square root of a product equal to product of square root, so we can split it. Yeah, we can write it as 10 plus minus square root of minus 1 times square root of 4 and times square root of 11, and all over 2. As a result, what do we have? 10 plus minus, this is our imaginary unit, this is our I, this is our 2, square root of 4 equal to 2, so 2i square root of 11, 2i square root of 11, and all over, right here we have 2. And our final step, we can easily factor 2 from our numerator, or we can divide this by parts. So 10 over 2 equal to 5, plus minus 2i square root of 11 over 2 equal to, so we can cancel this 2 equal to I square root of square root of 11. And right now, this is our answer to this question, but don't forget about this plus minus. So as a result, we have two branches, a first and a second. So let's write our first branch, a first equal to 5 plus I square root of 11, and our second branch, a second, equal to 5 minus I square root of 11. This is not our roots. This is, this is not our solution to this question. This is not our pair a first and a second, because in the beginning we had a question with a and b, and we have a really great expression because b equal to 10 minus a. So this is expression from the beginning. So as a result, we need to find our roots a first, a second, b second. So as a result, right here we can write b first equal to 10 minus a first, 10 minus a first, and right here b second equal to 10 minus a second. So as a result, let's solve it for b second. For example, b first equal to 10 minus a first right here on the top. So 5 plus I square root of 11. And b second right here we have 10 minus 5 minus I square root of 11. And I hope you see right now that we have two absolutely symmetrical pairs. What I mean right now, just look closer right here. So b first equal to 10 minus 5 minus I square root of 11. So 10 minus 5 equal to 5. So b first equal to 5 minus I square root of 11. A first, 5 plus I square root of 11. B first, 5 minus square root of 11. So two symmetrical pairs in terms of signs. And b second equal to 10 minus 5 plus I square root of 11. So b second equal to 5 plus I square root of 11. So the same thing right here. So as a result, we can write our two absolutely symmetrical pairs. So let's do it. So I'm going to write it as an answer, yeah, and then we will check it. So our answer, a first, b first, 5 plus I square root of 11, I square root of 11, and 5 minus I square root of 11, yeah? And second parentheses, 5 minus I square root of 11, these are a second, and b second, 5 plus I square root of 11. And in the end, let's check real quick our roots. First of all, I'm going to write our system of equations, a plus b equal to 10. This is our question from the beginning, so how it looks. So a times b equal to 36. One really interesting moment, because right here we have addition and multiplication, so we don't need to check both of these parentheses, both of these pairs, because a plus b equal to b plus a, so it doesn't matter what one of those we're going to use, it doesn't matter as a result. So as a result, right here we're going to add a plus b. So let's use, for example, these parentheses. So 5 plus I square root of 11. So we check this one, 5 plus I square root of 11 plus 5 minus I square root of 11. This one we're going to cancel, and we have a really classic answer, 5 plus 5 equal to 10. So the same thing as we have right here. So our addition works perfectly. And right now let's check our multiplication with the same logic. We can easily do this because right here we can write a times b as the same as b times a, so 2 times 3 is the same as 3 times 2, so it doesn't matter what we're gonna check, this one or this one. We have absolutely the same constant but with different signs, so basically it doesn't matter. So I'm gonna use, for example, first parentheses, so we have 5 plus I square root of 11 and 5 minus I square root of 11 equal to 36. Of course, we don't know exactly is this equal or not, but let's look closely right here. We have a product of two parentheses, but the main thing, what parentheses? We have in the first parentheses 5 plus I squared of 11 and 5 minus squared of 11. So if you know from school a really important identity, I hope you know it, like x plus y, x minus y. So what do we have on the left side? X squared minus y squared. So this is a difference of two squares. So I'm going to write it right here. So x squared minus y squared. Of course, you can easily multiply parentheses by parentheses, but using this formula, you save a lot of time. So we have x plus y and x minus y. Absolutely the same expression right here. So as a result, we can easily use this formula, x squared minus y squared. So I'm going to continue, for example, right here on the bottom. So 5 squared minus I square root of 11 squared. So 5 squared equal to 25. Right here we need to raise this this I to the power 2 and this square root of 11 to the power 2. So I square equal to minus 1, minus minus equal to plus, and square root of 11 to the power 2, we're going to cancel these two, and as a result we have only 11, so 25 plus 11 equal to 36. And we have the same expression right here. So our roots, our check is great. We solved it. We check our root, and I don't have enough space, so I don't want to rewrite this answer on the bottom. So here's our answer. Absolutely correct. Of course, you can easily check this from this branch, from this way, but you will have absolutely the same thing. Addition, we're going to cancel this expression, 5 plus 5 equal to 10. And multiplication, absolutely the same thing, because x plus y times x minus y is the same as x minus y times x plus y, the same difference of two squares. So this is my solution to this question. I really hope you understand it. I really hope you learned something new, but definitely don't feel bad if you got this wrong. If you need help with any of these classes, I have a lot of questions on my YouTube channel, a lot of different challenges. So I hope you enjoyed, and I hope this video is helpful in any way, because my main goal is to make math clear and understandable for everyone. And if this video is helpful, I'm really glad. I'm really happy that you learned something new. So wish all the best in life. Take care of yourself. Have a great day. See you in the next videos.